Hello fellow problem solvers. So today we're going to be doing a problem on polynomials. I made this little problem. I invite you to try it out for a minimum of 20 minutes, ideally 40, not more than an hour. And it's meant to illustrate what happens when we have these fixed, when we have a couple of values of p. So the problem says really it's a monic polynomial, and it's really trying to say like if we have n values of p given, we need to prove that this uniquely defines our polynomial. So if you want to go along with us, try and put your ideas on paper for the next 10, 15 minutes. And here's the big step. So when we have n values, right? We have n different values for p, a polynomial of degree n. An idea for me that I was trying to do was like, wait, let me try to write p as q times r, q times c, plus r for some polynomials qcr. Maybe the polynomial q will have x1 through xn as zeros, and then I'll have p is actually, and p of x and r of x share the same value many times. Maybe that's something interesting. And I couldn't finish it with that. I didn't know how to pick q to have a nice thing. So then I realized, okay, is there anything else maybe to do? And then I thought to myself, oh my God, this is phenomenal for one thing. And that is, as I say sometimes in this channel, mathematicians as good as they know how, as good as they are good at using induction. So here, how could we use induction? Right, so this thing is true if the degree of p is say 1, and we only have like p of x1 is equal to say y1, right? Then we have, this is ax plus b, and then this uniquely defines y1. In fact, how we could write this, how I would do this, p of x1 minus y1 is another polynomial of degree 1, call this p of x minus y, x minus y1, call this q of x. Q of x has a 0, which is at x equals x1. So this is x minus x1. It's a monic polynomial, so it's just x plus b. And then I have p of x is equal to x minus x1 plus y1. And if not yet. And that just finishes up our base case. Now, what if I have, now how can I go from actually p of x with n of these values to n minus 1 of these values? That's the big question. Pause for 10 minutes, figure out how. And here's the next step. So say p of x to the n, xn, is yn. Right. I'm going to do the same thing I did here. Let q of x be equal to p of x minus, what is it going to be, yn. And then I know q of x is divisible by y, is like for x equals x1, this is going to be 0. So I know q of x1 is 0, which tells me q can be written as q of x. Let's call it p2 of x times x minus, what is it? What's the 0? The 0 is, actually I made a mistake here, the 0 is xn. So x minus xn is a 0, so we can write it as this, in this form. And now what is p2 of x? Well, we have really p2 of x times x minus xn, right? We have this thing is q of x, which is equal to p of x minus yn. This is a polynomial of degree n minus 1. And we have, for x equals 1, for x equals x1 through xn minus 1, we will get, how many different values? We will get n minus 1 different values on this side. They can be 0, they can be non-zero. But once we divide by this, which is going to be non-zero because these are different values, we're going to get another polynomial of degree n minus 1. We know this is of degree n minus 1 because this is of degree, this here is of degree n, and this is of degree 1, so we know this is of degree n minus 1. And then by induction, we know that this polynomial is uniquely defined. And this finishes up our problem. And this was actually, for me, I had some trouble, trying to figure out, oh, how do I actually prove this? I had a strong intuition this was the case. I was like, wait, how do I actually prove it? And this is a proof I came up with. Now, I've been making these videos for a while today, and if I made a mistake, let me know in the comments below. If you have other proofs of this, please do let me know. This finishes up our problem. I think all these steps are valid from what I can tell. And as always, thanks for problem solving.